let's take a quick refresher at properties of exponents and exponent rules. Okay, so there are lots of different rules that you need to know and be able to work with. So here are some of the base rules. The product rule happens when you have like bases, x's, with different exponents. You can add the exponents together when you're multiplying between the bases. So an example of that is right here. X to the third times x to the eighth, you add the 3 and the 8 to get x to the 11th. All right, and then you see same thing happens right here. 2 to the fourth times 2 to the second will be 2 to the sixth because you add the exponents, the base stays the same. Okay, so the most important thing when you apply rules of exponents is that the base stays the same and the exponent only gets modified. Okay, the second rule is the quotient rule. When you have division between the bases, then you subtract the exponents. Division between the bases means you subtract the exponents. Okay, so looking at the first example that you see here, x to the fifth divided by x squared, 5 minus 2 is 3, so you get x to the third. Okay. The third rule is the zero exponent rule. Right? Any base other than 0 to the 0 power will always be 1. Okay? And that's a spin-off from the quotient rule. The reason why that works is this. Say I had y to the 0 had come from y to the fifth over y to the fifth. We know that that's y to the 5 minus 5, which is y to the 0. But we also know that anything divided by itself is 1. So that's why these two things are equal to each other. Okay? So any non-zero base raised to the 0 power will come out to 1. You'll talk about 0 to the 0 power when you get to calculus. All right. The next up is the power rule. Power rule is when you have a power raised to another power, then you multiply the powers together. Okay? So looking at example A here, x cubed to the second power, that means x cubed times x cubed. That would give you 3 plus 3 is 6. Or the shortcut is just do 3 times 2 is 6. Okay? All right. And then the expanded power rule that you see here, that's if you have multiple things being raised to a power, you can essentially distribute that power to everything inside. It happens when you have a product inside of parentheses or when you have a quotient inside of parentheses. Okay, so some examples of that are right here. So if you have 2a to the third, that's the same as 2 to the third times a to the third, and then 2 to the third you can reduce down to that 8a cubed, or 8a to the third. Okay. Now all these rules should feel pretty familiar to you. Again, this is just a quick overview. We're going to see some examples where they get much more involved. But this last one is going to be one that's going to pop up a lot, and that's negative exponent rules. Okay, negative exponent rules is if you have a negative exponent in the top, it moves to the bottom of a fraction. If it's in the bottom, it moves back up to the top. If you have a fraction to a negative, that inverts the fraction and makes the exponent positive. Okay, so read through all the different examples that you see here. If you have any questions, please let me know. Otherwise, I will see you in the next video where we're going to do some problems incorporating all these rules together. See you there.